Hello, this video is about finding an average value of a function using integration. This video we won't do even and odd functions, but we're going to try to find the average value of a function. So here, for example, is a graph of a function going from some interval from a to b. In this case, it looks like it's from 0 to about 9.5. And the point of this section is to try to find what is the value, what is the average value, what is it normally. So thinking about in life when you have to find the average of something, for example, you want to find your test average. Essentially what you do is you add up all the test scores that you have and then you divide by how many tests. So for example, you got, just to make it even simple, let's just say you got a 3, a 4, and a 5 on your exams. If I take the average, I add them all up, 3 plus 4 plus 5, which is 12, and divide by how many you have, which is 3. So 12 divided by 3 is 4. That's how you find the average. Okay, so just to repeat, remember you add everything up and divide by how many you have. Same thing with functions. What I'm going to do is I want to add up all the possible values I have of the function and divide by how many I have. This whole unit we've been learning how to find or how to add every value essentially underneath the curve is using the integral. So to use this formula, essentially I'm going to take the integral and divide by my distance, or quote-unquote how many I have. So here's the formula. I'm going to scroll down. It says the average value on a continuous interval, so it needs to be continuous, from some interval a to b, is 1 over b minus a, which is essentially dividing by how long the interval is, from a to b of the function. So here's an example, a good example of finding the average values. This one says find the average value of the given closed interval. So from negative 1 to 2, find the average value of 3x squared minus 5, or what value is this on average? Remember normally I need to figure out if my formula applies. It says a continuous interval. I know this is continuous because there's no denominator, there's no gaps, there's nothing in here that would make this function error. Okay. So what I'm going to do is I'm going to plug in this formula. Okay. I like to do the integral first because it makes sense to me. So I want to calculate what is the whole thing. Let me add everything up. Or in my example of test scores, let me add up all my test scores. So I'm going from negative 1 to 2 of 3x squared minus 5 dx. I know it's messy, sorry. So 3x squared minus 5 dx from negative 1 to 2. And then I want to divide by, the distance. How far am I going? Would you agree with me from negative 1 to 2, it's 3 units across. So from negative 1 to 2, it's 3 units across. So out in front here, I'm going to say 1 over, I'm going to put 3 because it's 3 units across. So, or in other words, once I take the derivative, or antiderivative, I'll divide it by 3. So I'll take the antiderivative. So this is something you should be familiar with or comfortable with. The antiderivative of 3x squared is going to be x to the third, adding 1, and dividing by 3 will just be 1, so 1x to the third. And the antiderivative of minus 5 is minus 5x. And then I have to integrate from negative 1 to 2. Okay. So remember, now that I take the antiderivative, what I'm going to do is plug in negative 1 and subtract the answers. So I'll call this 2 to the third minus 5 times 2. Actually, I'm going to put another set of parentheses here. Minus, I'll plug in negative 1. Okay, so far? So all I did is plug in 2 and plug in negative 1, and I'm going to subtract the two quantities. If I plug in a 2, okay, I'm going to get 8 minus 10. Okay, 8 minus 10 gives me negative 2. Then the minus. If I plug in negative 1, I get a negative 1 plus 5, which is 4. Negative 1 plus 5. Negative 1 plus 5 is 4. So now, negative 2 minus 4 is negative 6. And negative 6 divided by 3 is negative 2. So what you found, again, is on average, this function between negative 1 and 2 usually or on average will return, or the values on average, about negative 2. Okay? Does that make sense? So hopefully you guys understand a little bit about average value. It's just integration again, but dividing by how long the segment is, or the interval is. Let's do it again, but now with a graph. So here it says the graph of the function f is shown below. So they're not giving you an equation, instead they're giving you a graph. And it says find the average find the average value from -8 to 6. So again, I like to do the integral first. So from -8 to 6. There's no equation in this problem, so I have to write f of x dx and then figure out again how long is this interval. If I'm going from -8 to 6, would you agree with me that this segment is, or this interval is 14 units long? So can you guess what function, or sorry, what fraction I put out in front? It's going to be 1 over 14. Okay. So some of you may say, how do I do this part now? Okay, from -8 to 6 if there's no equation. Well, with the graph, I need to literally calculate what is the area between -8 and 6. So here's -8, right, goes over here, and here's 6. So I need to find the area under the curve from these two parts. Well, from here to here, you see there's no curve, so this is nothing. From here, do you see I have a triangle? And from the last video, I told you if it's underneath the x-axis, it's a negative value because this is technically -2. So remember, the area of a triangle is half base times height. So do you see how my base is 2 and my height is -2? So it's going to be half, or the area of that triangle is half -2 times 2, or -4 over 2, or this whole triangle, its area is -2. This one's a weird shape. You may notice that it looks like the fourth of a circle, right? See that? So I need to find the area of a circle and only take a fourth of it. So the area of a circle, remember, is pi r squared. So if I think of this as a circle, do you see how my radius is 4 units across? So my radius is 4. So this whole circle right here is going to be pi 4 squared, or the circle is 16 pi. But remember, I don't have a whole circle. I only have a fourth of a circle. So a fourth of 16 pi is 4 pi. So this whole piece right here is 4 pi. From 0 to 3, you may notice that I have a trapezoid. So you see I got a trapezoid. I'm going to take half of the bases and then multiply by the height. So my height is 3. Okay. My first base is 4 and my second base is 2. So if I take half of the bases, like if this is 4 and this is 2, the total is 6. Okay? And taking half of that is 3. So if you guys feel more comfortable seeing the formula, base 1 plus base 2 over 2 times the height. So this was 4, this was 2. Okay, so it's 6. 6 divided by 2 is 3. My height is 3, which means the area of this whole trapezoid is 9. I got a very, very tiny triangle right here. My base is 1. My height is 2. Multiplying that is 2, and taking half of that is 1. And here again, I got a triangle that's beneath the x-axis, and I can tell because my height's going to be negative. Same thing, an area of a triangle, I have 2 across. I have -3 as a height, which is -6, and half of that is -3. So you use your area of a triangle to find the area. So now all I'm going to do is add them all up. I have 10 plus 4 pi. I can just leave it like that. 10 plus 4 pi. I'm subtracting 6. So I have 10 plus 4 pi. Oh, sorry, not 6. Minus 5. So the whole area under this curve is going to be 4 pi plus 5. I know some of you, it drives you crazy that you don't have an actual number, or like you want to put this into a calculator, but you can just leave the answer as 4 pi plus 5. But that's not the whole problem. Remember, the whole problem is find the average value. So this whole thing right here, this integral f of x dx, this whole thing right here turns into 4 pi plus 5. So I still have 1 over 14. Might be easier for me to delete this. 1 over 14 4 pi plus 5. And you know that there's nothing that simplifies here, so you can leave it like this, or you could say it's 4 pi plus 5 over 14. It's not a clean answer, but it's the answer. Okay. Any questions about that? It's not so bad. Okay. This one I'm going to skip over. Which of the following? It's going in reverse. They're giving you the formula, and they want you to figure out the graph. But we're going to skip over that. Okay. And the last one, just like everything we've been doing, is we've done it with a function, we've done it with a graph, and now we're going to do it with a table. So this one says, what's the average rate of change from -2 to 3? So same thing. I will do -2 to 3. And you see how there's no equation? So just like last time, I'm just going to call it f of x. I'm having problems writing, so I'm just going to type it. And from -2 to 3, you notice that this segment is how long? It's going to be 5 units long, so out in front I'm going to put what fraction? 1 over 5. And I don't want to forget the dx here, so f of x dx. Alright, so again, with no equation, I need to figure out how much is this, or essentially what is the integral from -2 to 3. Okay. So what I'm going to do is, since I don't know what the antiderivative is, what I'm literally going to do, or what I'm going to have to do, is I noticed that it wants the average rate of change. And you know the average rate of change is f prime, because it says rate of change. So what I forgot to put in my original formula is I need to put like an f prime. So I need to know from -2 to 3, the antiderivative of f prime. Would you agree the antiderivative of f prime, as we learned last time, when we had to solve this, is the same thing, and we're learning backwards from what we learned last time, is the same thing as remember doing that last unit? Remember we said the antiderivative of a derivative is the same thing as f of 3 minus f of -2, or these two, or f of b minus f of a. Remember doing something like that? So what I need to find out was f of 3. F of 3 is 0. Okay, so I still have this 1/5 out in front. And here, let me rewrite the problem. F of 3 minus f of -2. Okay. I still have the 1/5 out in front. Like I said, when I looked up at the table for f of 3, I noticed that f of 3, here's f of x, and I go all the way down to 3 is 0. And f of -2, here's -2. F of x is 7. So 0 minus 7 is -7, and divided by 5, your answer is going to be -7 over 5. So again, we're sort of using some review from the last section. If ever I need to find the antiderivative of the derivative, remember it equals the f of b minus f of a. And we did a whole bunch of that all last week when I was gone. Alright, last one that we have time for. What's the average rate of change of f of prime over the interval -2 over 4? Okay, so just to make this quick, I know that this is 1 over 6. I know that this is -2 to 4. And I know that this is f, and I want the average rate of change of f prime. So if I want the rate of change of f prime, if you remember this is the average rate of change of f, I had to put an f prime. That is a hint for you. If I want the rate of change of f prime, I need to put an f double prime. There you go. So just like the last time, what I'm going to do is I remember what my formula is. If I'm trying to find the antiderivative of the derivative, in this case it's the second derivative, it's the same thing as f of b, which in this case will be 4, minus a, which in this case is -2. Okay, so far? So 1/6, and this time, since it's f double prime, I'm going to look at the f prime. So how about this? I'll put the f prime up here so you understand. And you can fill it all out, but f prime of 4 is 2, f prime of 4, -2 is 0. So you just solve that. I'm out of time. Hope you understand, and I'll see y'all in class.